The next trend we're going to discuss is something called ionic radius. It's very similar to the atomic radius, which is the size of an atom at its neutral state. An ionic radius, just like the name implies, is the size of those atoms when they are ionized or have a charge. Okay, so again, you guys know the words cation. A cation refers to a positive charge. So these are positive. Anions, as you guys know, are negatively charged ions. So between a regular calcium atom, which is uncharged, and a calcium with a +2 charge, again, notice it's 2 plus. That is correct. It's not wrong. You could do +2 or 2+. That's just, again, a different way of showing that right there. So a neutral calcium atom has an equal number of protons and electrons. So there's a good balance, a good attraction between the electron cloud out here and the nucleus in the very center. When it's a calcium with the +2 charge, remember a +2 means it's lost 2 electrons because electrons are negative. So to become a positively charged atom, you've lost 2 electrons. So that means there is 2 less electrons. So ironically, the attraction is actually weaker. It's actually going to be weaker. So this is going to be the larger of the two because there is less attraction between the negative electrons because there's 2 less of them and the protons in the nucleus. So there will be just a little more relaxed, a little bit larger. Okay, the more electrons you have, the more attraction is going to pull it in tighter, which takes us to an anion. In this case, we have nitrogen at a neutral state and nitrogen with a -3 charge. -3 again means you have 3 extra electrons, 3 more electrons in the neutral form. Therefore, there is a greater attraction between the electrons out here and the nucleus in the center. So it's going to pull it in just a little more tightly. So the larger of the two is actually going to be the neutral form. Okay, so in this case, it says which particle is larger in radius? Astatine with a -3 charge or just regular, I'm sorry, that's arsenic. Arsenic with a -3 charge or just regular arsenic. So arsenic, again, with a -3 charge, like I said, for the anion example, is going to have a greater attraction. So it's going to pull it in a little tighter. So it's going to be regular arsenic because, again, there is a normal number of electrons, not an extra number of electrons in the -3 form. Here we have iron, Fe, with a +3 charge and iron with a +2 charge. Again, +3 means you have lost 3. So there's less attraction from the electron cloud to the nucleus. +2 means there are 2 less electrons. So the larger of the two would be the one with the less electrons, which would be iron +3, or iron with a +3 charge. That one would actually be a little bit bigger because, again, there's less attraction. It's going to be a little bit more relaxed, a little less squeezed and confined. The next one we have is 3 forms of oxygen. So we have the regular ion, or excuse me, the regular atom, a -1 and a -2. Again, more electrons mean more attraction with the nucleus. This one would be the smallest. This would be the next smallest. So the largest would be the neutral form of oxygen. Next one is silver ion and a neutral silver atom. Silver is Ag, and as an ion, it's always going to be a +1 charge. That's just one of those weird exceptions. It's a transition metal, and normally they could really have different charges, but silver, zinc, and cadmium, I didn't just cheat, silver, cadmium, and zinc always have a very specific charge. Silver always happens to be a +1. Or just regular silver, which is Ag. Again, if you follow the pattern up here, you notice that anything with a +1 charge is actually going to be bigger because it's less constricted, less squeezed. Therefore, this would be the larger of the two. The regular silver atom would be a little bit more squeezed in because it has an equal number of electrons and protons. Sorry guys, just blanked out there for a second. All right, the next thing is, I'm actually gonna stop right there. Let's make that nice, short, and sweet.